Okay, here's just a couple of examples since you've been doing the investigations out there on your own. I figured it might help you out. So we're going to start here, and it says AB and AD are tangents. And one of the properties that you should have learned is that if there is a tangent, that tangent is 90 degrees to the radius. So what you can see is the radius CB and the tangent AB are connecting here at this point of tangency. Therefore, this is going to be a 90-degree angle. And I'm just going to mark some of the same properties out there. And then you'll see CD and AD. AD is a tangent, and CD is a radius, so that also needs to be 90 degrees in there. And because of that, we can actually go ahead and find X pretty quick, because we know that we have a kite, we have got a quadrilateral, and a quadrilateral has 360 degrees in there. So I could take that 360 degrees. I know that I've got a 90-degree angle at B. I know I've got a 90-degree angle at D. And I've got a 58-degree angle. So I can subtract off 180 and then subtract off an additional 58 off the top. And once we do that, we can find that we're going to have about 122 degrees. So X would be 122 degrees. One of the other properties that we figured out is, since we have a quadrilateral that is being made with the tangents AB and AD and those radii, we know that this is equal right there. And one of the properties of a kite is that this is congruent to that. So AB and AD are also congruent. So if two tangents intersect, their points of tangency are the same distance away from their intersection. So we can go ahead and say, well, Y is equal to 16. Then we've still got to find Z over here. And one of the other properties that you learned earlier in this section was that the central angle, or if you read the notes that I've given you, the central angle of 122 is the same as the arc. So if that's 122, this is also 122. And we know that in a circle, there are 360 degrees. So I could take 360 degrees and I can subtract off that 122. And when we do that, we're going to find that we have 238 degrees. So that would mean that Z is a major arc. It is above 180 degrees. I'm going to go ahead and just do another one just to help out. So I'm going to scroll down to another problem right here. And I'll go through this one pretty quickly as well, because it holds a lot of the properties that we've been talking about already. So there's lots of things going in here. We're going to find X, we're going to find angle A, we're going to find angle Y, and kind of work from there. The first thing I'm going to do is identify X. I think that's the easiest one right away. It was the first property that we really learned, was that if we have a radii, so like, for example, in this case, if I have a radius, okay, and it takes a chord at a 90-degree angle, and you can see that in the diagram there, that's got a little 90-degree box in there. And what it does is it bisects it, or it cuts it in half. So this 3 is the same as that 3. So X has got to be equal to 3. It's going to cut that in half. So that goes ahead and clears, helps out there. So let me go ahead and get rid of that. So this X is going to be 3. Once we have that, I can go ahead and start working with this 225 degrees. There's not very much other information on this diagram. So it says DCB, D to C to B, telling us that it's a major arc, is 225 degrees. Well, if this right here is 225 degrees, that tells me that I can go ahead and find this right there, because how many degrees are in a circle? I know that there are 360 degrees in a circle. So to find this red arc right here, I can just take 360 degrees. I can subtract off the 225, and that's going to leave me with a total of 135. So this is going to be 135 is what that arc is. Well, if this is the arc and it's 135 degrees, I also know that central angle is 135 degrees. So I say, okay, well, Y has got to be 35 degrees. Okay. Let me erase that because it's getting just a little sloppy there. So that tells us that that is going to be 135 degrees. And that tells us, so we've got x equals to 3, and we've got y equals 135 degrees. And now what we need to do is come in here and find a, okay? Well, it doesn't tell us that A, B, and AD are tangents. However, what it does do is it tells us that A, B, and AD are the same length. And one of the properties you should have figured out in our investigations is that if they're the same length and they intersect the circle at a radius, that means they are going to be tangent. And so we're going to say that we know that this is 90 degrees and that is 90 degrees. Okay, once we've got that information, we just go back to the exact same thing we've been doing. A quadrilateral has got 360 degrees. I'm going to subtract off the 180. The 180 is the 290s, by the way, if you haven't figured that part out. And then I'm going to subtract off the 135 that is making the length or the angle of y. So once we do that, we should find that this is a 45-degree angle. 5-degree angle. And so we're just using a bunch of those circle properties that we've been talking about or you've been investigating on your own there. Hopefully this helps you out.